Peter, suppose you want to find the volume of a cylinder. How would you set up the integral?
Easy. I just fill it with beer and measure how much I drink.
Charming. But mathematically, we need a triple integral over the cylinder's volume. Here's our cylinder. Radius r, height h. We need to integrate over every point inside. In Cartesian coordinates, it looks like this. Notice those square root bounds? Absolutely hideous.
Whoa, that's more complicated than my tax returns, and I don't do those.
The problem is the circular cross-section. In Cartesian, the y-bounds depend on x through that square root. It's a computational nightmare.
Can't we just use different coordinates or something?
Precisely. We use cylindrical coordinates instead of x, y, z. We use r, theta, and z. R is the distance from the z-axis. Theta is the angle around like a clock, and z is still just height.
So antitheta handle the circle part, and z handles the up and down?
Exactly. The cylinder becomes trivially simple. Ray goes from 0 to r, theta from 0 to 2 pi, z from 0 to 2 pi, z from 0 to h. Beautiful constant bounds. The integral is now gorgeous, but wait. What's that extra fraud doing in there?
Did someone sneak in an extra letter?
That r is the Jacobian. When you change coordinates, you need to account for how the volume element transforms. Think about it geometrically. Arc length grows with radius. Your slices get fatter as you move outward. The factor accounts for this.
So, forgetting the Jacobian is like forgetting to tip? You'll get the wrong answer?
A crude but accurate analogy. Without the Jacobian, your integral is worthless. Remember, dx dy dz equals rd theta dz. That r is non-negotiable. And solving our cylinder integral, it evaluates to pi r squared h, the classic formula, derived rigorously.
So cylindrical coordinates turn a nightmare into a cakewalk? Why don't we always use them?
Because not every shape is cylindrically symmetric. You dolt. Match your coordinates to your geometry. Follow for more.